Hello everyone, thank you for watching. I'd like to present our visualization project in which we analyzed and compared the way languages sound. So modern languages essentially form a family tree. This is a hierarchy of languages with child languages that evolved from parent languages, and there are also different branches of languages as you can see here. So we wanted to know the extent to which closely related languages in the tree are similar in terms of their pronunciation. Now, in order to represent the way certain words of a language are pronounced, linguists in the late 19th century developed the International Phonetic Alphabet, or the IPA, which maps sounds to letters. So it's a notation that captures how words are supposed to be pronounced, and you can see this notation often in dictionaries. Now, besides the main symbols for the sounds, which are primarily based on the Latin script, the IPA also provides so-called diacritics and suprasegmentals to further modify those sounds in a detail or nuance. For example, the colon after the U indicates that the U sound has to be held slightly longer, and the small superscript H indicate that the T is supposed to be pronounced by quickly breathing out. So for our research, we collected a list of the 1,000 most common words in English and their translations to a number of other languages. We then transliterated these words to their phonetic counterparts using a Python library called epitran. Then we counted both the number of phones, which are the universally acknowledged sounds, and bigrams, which are sequences of two phones, and we counted these for each language. We then visualize both the phone frequencies using a bar chart and bigram frequencies using a weighted adjacency matrix. And both these idioms are used to compare up to two languages at the same time. So each location in the adjacency matrix, which we will also call a heat map, corresponds to the frequency of the bigram consisting of the phone on the x-axis followed by the phone on the y-axis. We use squares to indicate that the bigram occurs only in the first selected language, and we use circles to indicate that the bigram occurs only in the second selected language. Then we use triangles to indicate that the bigram occurs in both languages. So the color is used to categorize the different languages, and we use saturation to indicate the magnitude of the frequency. Alright, so let's look at a demo of our visualization. Alright, so this is our implementation using D3. Now at the top I have selected two languages to compare, in this case Spanish and Portuguese. And we can see the phone frequency, which is shown as a grouped bar chart. You can actually hover over the individual bars to get the values of the phone frequencies of both languages. And we can also view the bigram frequencies in the weighted adjacency matrix, where the squares indicate Spanish and the dots indicate Portuguese. And you can actually see that they are quite similar in terms of their distribution. So even though they don't share the same bigrams as often as you would expect, they do have bigrams that lay very close to each other, meaning that they share phones that are sounding very similar to each other. So also if you look at the bar chart, you can see that the phone frequencies are quite similar, meaning that the lengths of the bars are quite similar, meaning that in general these languages sound similar, and that sort of confirms what we expected with them laying close to each other in the family tree. Now, if you look at Hungarian and Bengali, which are two languages which lay quite far away from each other in the family tree, you can see that the phone frequency distribution is actually quite different. So this is also expected. And if we look at the bigram frequencies in the weighted adjacency matrix, you can also see that bigrams do not lay close to each other, and they do not have a lot of shared bigrams, which are denoted by the triangles. Now, a last feature that I can show is you can select and filter bigrams based on their minimum count. So if we only want to show bigrams that occur more than 20 times, then we can filter it on that. So these results basically indicate that closely related languages indeed sound more similar than languages spaced far apart. And that's it. Thank you for your attention.